First half of section 8.3, inequalities with absolute values. So we've already said that an absolute value is a distance from zero. And so we're going to deal with inequalities that have to do with absolute value. Now in this section, we're going to deal with the less than and the greater than separately. We're going to do the greater than in the next section. All we're going to deal with is the inequalities that use the less than sign. So something like this. The absolute value of x is less than 4. Now what that means is the distance that our answer is less than 4 away from 0. So we have a number line here with a 0. We can go up to 4 positive, but we can also go down to -4, and anything in between here would have a distance of less than 4. 2 has a distance less than 4. -1 has a distance less than 4 away from 0. So the absolute value of an inequality, if it's less than, then it's going to be in between the negative and positive of our two endpoints. And so this ends up being -4 is less than x, which is less than 4. So if you'll remember, this looks a lot like our and, or our why am I looking for the word isolation? That's not the right word I'm looking for. Intersection. Thank you. So this is the same as our intersection compound inequality. So that's what we're going to end up doing. What we'll do is this. When you solve an absolute value inequality with a less than sign, now it has to have less than in order for this to work. The first step, again, is to isolate the absolute value. You've got to get the absolute value by itself. Once you get that absolute value by itself, then you're going to make two inequalities. You're making a compound inequality. You're making an and, or an intersection compound inequality. You're going to set whatever your absolute value is, and you're going to say that is greater than, you're going to switch the sign and say greater than negative whatever you got, and then your absolute value is less than. So this one is going to be the same as your original, all right? So what we've got here is the absolute value of x is less than 4. So x is less than 4 stays the same. And then we also have x is greater than -4, or -4 is less than x. So those are our two different parts, and then once we solve and graph, then we're finished. So let's do a couple so that once you understand how to set them up, solving it is a piece of cake. You already know that. So what we're going to do is, step 1, isolate the absolute value. Well, in this problem, it's already done. So now we want to make our two inequalities. So this x stands for the absolute value. So the absolute value, the x minus 4, you're going to switch the sign and say that it's greater than, in this case, greater than or equal to negative of whatever your answer is. So -3, and the absolute value, so your x minus 4, and then keep the sign less than or equal to, and keep your answer positive. Okay, so once you've got those parts, now it's just solving. So what you're going to do if it's less than, you're going to keep the absolute value, switch this sign and say it's negative, and then take your absolute value and just remove the absolute value signs and keep the same inequality that you did before. Okay? So then you're going to just solve it, add 4 to both sides. So x is greater than or equal to 1, and you're going to add 4 to both sides here, and x is less than or equal to 7. So here's our two. So now we've got, we can set it up in a compound inequality. 1 is less than or equal to x, which is less than or equal to 7, and then graph it. 1 and 7 are our endpoints, and they're hard endpoints, and x is in between them. So the absolute value, the distance that x minus 4 is less than 3. So you can pick a number in there and try it. So say 2. 2 minus 4 is -2. The absolute value of -2 is 2. Is 2 less than 3? Yes, it is. So we're good to go. All right? So let's try another one. The absolute value of 3x plus 1 is less than 5. Same thing again. The absolute value is already isolated, so that part's done. So what we're going to do is we're going to set it up. We're going to first take the absolute values away, switch our sign and say it's negative. And then we're going to take the absolute values away and just leave it alone. So 3x plus 1 is less than 5. And the and is what's in between. So now subtract 1 from both sides. 3x is greater than negative 6. Divide by 3. X is greater than negative 2. Subtract 1 from both sides on this one. 3x is less than 4. Divide by 3. Ooh, so it's a fraction, but you know what? It's okay. X is less than 4/3. So set it up in your what is that called? Compound inequality. Negative 2 is less than x. Do you see that when I flip-flop it, I just the inequality symbol is still pointing toward the negative 2. Now the 2 is over here. It's pointing toward that. And now is less than 4/3. And then set up your graph and shade in between those two symbols, or those two endpoints. Okay, the next one, let's isolate the absolute value, subtract 6 from both sides. 1/3 x minus 4, the absolute value of that is less than negative 7. All right, can the absolute value be less than a negative number? No, it cannot. The absolute value is a distance. A distance is always going to be positive. So the absolute value is always going to be positive. It can never be less than a negative number. So this one is the null set, empty set, no solution, however you want to put that. So null set or no solution. Okay? So if you end up with an absolute value being less than a negative number, your answer is no solution. Okay, let's do one more. Isolate the absolute value. We're going to add 2 to both sides. Negative 1/3 x plus 1, absolute value, is less than or equal to 2 plus 1 is 3. So now set up our two inequalities. Get rid of the absolute value. Negative 1/3 x plus 1 is greater than or equal to negative 3. And now get rid of the and. Get rid of the absolute value, negative 1/3 x plus 1, and keep it the same, less than or equal to 3. Subtract 1 from both sides. Negative 1/3 x is greater than or equal to negative 4 times, what we're going to do is flip-flop the negative 1/3, so times negative 3 over 1. Remember, if we're multiplying or dividing by a negative, you got to flip-flop the sign, times negative 3. So x is less than or equal to negative 4 times 3 is 12. Solve this one, subtract 1 from both sides. Negative 1/3 x is less than or equal to 3 minus 1 is 2. Once again, times a negative 3, so you're going to switch your symbols, times negative 3. So x, switch it, less than or equal to 2 times 3 is a negative 6. So now when you set up your compound inequality, and I'm getting close to the end of where you can see, so I'm going to put it up here. So now we've got x is less than negative 12 and x is less than negative 6. Sometimes it's easier for me to actually graph it first. So negative 6 would be here, and negative 12, remember if you're going negative, you're counting backwards there. So x is less than negative 12. And x is less than negative 6. So it goes this way. So if that's the case, then let me make sure that I didn't make a mistake. I did something wrong here, didn't I? Oh, man. Oh, guess what? I knew this is a problem. I didn't switch my symbols. X is greater than. I did exactly what I said, watch out for. I multiplied by a negative and I didn't switch my symbols. x is greater than negative 6. So now here's the problem. Did I do something wrong? X is greater than negative 6. So, guess what? I'm doing all sorts of things wrong. I was like, why is this not working? Guess what? Negative times a negative is a positive. So now are you totally confused? I hope not. Negative times a negative is a positive 12. This is why it wasn't working. I was wondering what was going on. Okay, now we've got all the parts right. X is less than or equal to 12, and x is greater than or equal to negative 6. So now when we put it on our number line, it should work out right. So this is a good example of if it's not working out, put it on your number line. If it's not working out quite right, go back and look and see, oh, did I make a mistake here? All right, so 12 is going to be up here, and we've got less than 12, so this direction. And x is greater than negative 6 is this way, and we want what's in between there with hard ends. So x is between negative 6 is less than x is less than 12. And that is our solution. That should not have been that hard. Oh my goodness. Okay, so the biggest thing is this. You already know to isolate the absolute value. This is the part, this second step. If it's a less than symbol, if your absolute value is less than something, then you're going to make two inequalities. This is going to be an and compound inequality. So you're going to take your first one and switch the symbol and make it negative, and then take your second inequality and leave it exactly the way it is, just removing the absolute value symbols. All right, you can do this. Here we go. See you later.